Welcome to the Trend Detection Podcast, powered by Siemens.
Hello, everyone. Thank you for joining our webinar, Unlock the Power of Data-Driven Manufacturing, Digital Strategies to Accelerate Manufacturing Growth, presented by Ronak Makwan and Hinaro Kiraz. Today, they'll be talking about how technologies like CMMS, predictive maintenance, FCA, IoT, remote monitoring, and machine learning can streamline your operations. The role of data in capital planning, asset lifecycle management, and how reporting and analytic tools can help you achieve your financial goals with confidence. Before we get started, I want to just go over some easy housekeeping items. All of your lines are muted during the session. Please submit your questions through the Q&A feature at the bottom of your screen at any time during the webinar. We'll answer questions at the end of the presentation. If you don't see the Ask a Question box, you can open it with the question mark icon at the bottom center of your screen. The presentation is being recorded and it will be available on demand after the webinar. We'll also send it via email with a link so that you can come back to it or share it with colleagues. It usually gets sent within 24 to 48 hours. I'd like to introduce our two speakers for today. With over a decade of hands-on experience in both maintenance and engineering roles, Ronak brings a wealth of experience in GMP, HACCP, and BRC programs. Ronak's experience includes lean manufacturing and total quality management environments, maintenance management in fast-paced environments, and a deep understanding of building automation, PLC systems, and equipment integration projects. Driven by innovation and a passion for process improvement, Ronak is well-versed in non-value-added elimination principles and has demonstrated successful project management skills in manufacturing plants, spanning initiation, execution, monitoring, and controlling and closing. Ronak is a professional engineer with his Red Seal Journeyman Electrician ticket and has a PMP certification. He's based in Toronto. Hinaro Kiraz is the solutions engineer at Siemens, specializing in AI and predictive maintenance. He leverages AI to revolutionize traditional maintenance strategies, driving sustainability and innovation. With extensive experience as a controls engineer, industrial technician, and U.S. Navy submarine electrician, Hinaro understands the critical importance of reliability, efficiency, and continuous technological improvement. He has successfully deployed projects globally, making AI a reality that delivers tangible outcomes across various industries. Now, I will pass it over to our two speakers to get started.
Awesome. Thank you very much, Stephanie. That was a great introduction about myself and Hinaro. So hello, everyone. Good afternoon to those who are joining us from the Eastern Standard Zone, and good morning, whoever is joining us from the Pacific Time Zone and the Central Time Zone. So myself, Ronak Makwan, I come from the manufacturing industry, working mostly in the food and bev. I work in maintenance, operation, as well as the engineering role. And today, I'm thrilled to talk about all the different digital technology, what we have available in the current market that can help manufacturers run their day-to-day operations and maintenance. So before I start talking about all this technology, let me get into a visual representation, what we call as an asset pyramid. So when you look at this asset pyramid, that's the entire visual representation of your entire asset management journey. So if you buy any asset, and I'm just going to give you a very basic example. Let's say if you buy a brand new boiler or a brand new air compressor, you always start from the very bottom layer, which is the work management processes. So work management processes, whether it's a part inventory management, whether it's a work order management, whether it's a material management, whether it's an asset registry, to start building it from the scratch. Those are some of the core fundamental items that every organization, every manufacturers, every maintenance department should and must follow if they want a robust strategic asset management program. So that would be the most foundational item. Then when you look at the second bottom layer, how you envision your asset management journey, now you have the work management, now you have the asset registry, now you have all your parts in place. Now you start implementing processes to maintain your day-to-day operations. So what type of process that would be? So a very basic that can go with any companies is RCA, root cause analysis, reliability team, different maintenance strategies such as PM compliance program, work design standards. So those are the processes that will help manufacturers to stay on top of your work order management, to detect any reactive failure and act on it and basically work in a proactive mode rather than a reactive mode. So that would be the second bottom layer. After that, now we are started to going into digital mode. Now we are talking about the operational technology. First, you already have your work order management. Now you have implemented the personnel, the manual processes in place to look after those work management processes. Now, let's get into the operational technology, and we'll be touching all of them in our next slides. For example, CMMS, or IoT remote monitoring, or predictive maintenance, or FCA, building automation system, or SCADA, which is supervisory control and data acquisition, that links all of your moving existing production equipment into a single screen. So the idea here is you want to have a full vision of your manufacturing industry, of your production environment on a single screen. So if I'm a plant manager, if I'm a senior level executive, if I want to understand, hey, what's happening as of today, April 9th, how's my day shift doing? What did they do in the last 6 hours? Those operational technology will provide them that information and data. Then we get into the performance management, and that's where we're talking about the reporting and analytics, which we'll be touching in our next slide as well. But that's where now you already have that defined data available. Now you talk about strategy. Now you talk about how you can leverage that information, that data that can take you to the next level, which is the strategic asset management journey. That will help you and equip you to increase the overall equipment lifespan. And then we will end up into asset investment planning, which most of the manufacturers call capital planning, right? But in a nutshell, it's a synonym for asset investment planning. How are you planning and managing your assets? So this entire pyramid, what we call, and this is very near and dear to my heart because that provides you a very broad level understanding of how you would like to manage your assets. If you are on an intermediate level, if you are just starting your asset management journey, or if you are on a well-advanced level, that will tell you where you are and what would be the next step in your journey. So just want to start this conversation from this pyramid so everybody has a clear understanding of what would be an ideal asset management journey look like for any organization. Moving on, so everyone knows everything starts from data, right? So let me give you an example. And as I said, I come from manufacturing. Every morning in my previous work life, as soon as I go, the first question I was asked, hey, how did we do yesterday? What was the equipment downtime? What was the production throughput? What was the overall equipment effectiveness? Because that's what everybody wants to know, and everybody is keen to learn about the numbers, the projections, the performance, right? So what is the center of everything? It's the data. But let me ask you, everyone, and you can ask yourself, just providing you with the numbers and just providing you with the raw data, will that be helpful to make any judgment or any strategic decision? No, right? Because you need to convert data. And that's why I have created this slide, which explains exactly what is the difference between data and information. So as I said, data is just a raw information that is coming out from any software. So for an example, if you have a CMMS implemented, it will provide you raw information about, let's say, previous day, you did 50 preventative work orders. But how you leverage that data? So in a layman term and a laywoman term, when you convert data into actionable insights, when you tie in actions against those numbers, that's when magic starts to happen. And that's where you start seeing different trends, different areas of what is trending and what is not trending. For example, let me give you an example. If you get a trend of all your production equipment for last 1 week, now you are comparing that trend into information saying, hey, one of my production filler is constantly going down for at least 1 hour per shift. So now you have a trend. Now you have the data for last 7 days. That equals to almost 30 some hours worth of downtime just on one single piece of equipment. So now, based on that information, now you can start thinking more proactively to go back and talk to your maintenance team, talk to your maintenance supervisor to understand what is the root cause, why we are losing every day 1 hour on a single piece of equipment, right? So just wanted to give you a more basic example to understand that only raw data cannot help. You need to come up with the trends. You need to attach that with your actionable insights. And you need to understand what is your end goal. If you have the data, How would you like the data to interpret to provide your end goal? Is your end goal to improve the equipment efficiency? Is your end goal to improve the quality product that you produce? Is your end goal is to reduce your maintenance costs? So based on that, you can leverage this information, leverage this data that can help you moving forward. Okay, so that based on that information, let's talk about CMMS, because I already mentioned CMMS almost few times already in this session. So CMMS, which stands for Computerized Maintenance Management Software. Most of you who are already here, they must have either heard this terminology or have used this terminology. There are multiple, I would say, number of different CMMS softwares that are available in the current market right now. There are some which are more basic. There are some which are intermediate. There are some which are well advanced. So that's where, if I were you, I would first understand what is my use case. First, you need to ask yourself, is it you need to buy a Siemens because your maintenance cost is very high and you don't have any data to support why your maintenance cost is going high, you don't have any information? That's one point. If you are increasing unplanned equipment downtime and you don't know how to fix it, that's another use case. Spare part inventory budget. Like, this was a very, very big issue for me in my previous work life. Spare part inventory management, right? Because the inventory management is a very, very big, people think it's a back burner, but it's not. According to me, I have seen almost close to $1 million worth of write-off every fiscal years because we are not tracking inventory accurately. Maintenance staff, maintenance trades are not signing out motors, gearboxes, bearings that they use it. They physically use it on the piece of equipment, but they don't follow the process. So is that your use case? Missed production goals, that goes hands in hands with the equipment efficiency. Your customer confidence. So when you are tracking your customer fill rate, is your customer fill rate is going low? If you are getting more customer complaints, that becomes your another use case, right? And the last, but not the least, and this is the center of our today's topic, lack of data. If you don't have data, and I was in that situation in previous work life where I joined the company, I'm the leader of the maintenance department. I was told to start leading the maintenance, but hey, we don't have any historical data because we are using a legacy software which can only do minimum tasks, which does not have a capacity and capability to tell me what happened in this particular facility for past 2 years. So that can become my big use case. And based on that information, I went ahead and I install and implement a brand new CMMS system. So how do you define a well-designed CMMS, right? So when I look at any system, and regardless of whether it's a CMMS, whether it's a capital planning system, there are three main pillars for those systems. You need to understand the technology. The technology, is it meeting your demands? Is it meeting your needs? Second is the people, and that includes management as well as the first-hand operators, maintenance trades, because they're all going to use this, right? So you need to have that understanding, that people skill in mind to see, hey, if I buy this particular software, will that be helpful for my current workforce, right? And the third piece is process, that you need to understand that whatever the system and software you buy, will that be integrated into your ERP system? Most of the company use SAP, IBM Maximo, Oracle, JD Edwards. So there are different ERPs, there are different CMMS, but will they integrate together? And that is very, very common questions. Every manufacturer has it in mind. So these are some of the use cases and some of the benefits. If you have a well-designed system, the first and foremost thing, that one of the huge benefit for me in my previous work life was, you increase your equipment life expectancy, you produce more quality products, you meet your production goals. So that's the bread and butter for any manufacturer. You need to complete your production goals. If you are told to finish 2 million pounds worth of ketchup, or if you're told to do 2,000 cases of finished product on a weekly basis, that's your target. You need to meet that target. If you overachieve that, that's wonderful, but you need to meet that minimum target levels. You need to make sure that you are attaching and you are meeting all your regulatory compliance needs as well. And most important, you can track all your assets, all the inventory which is attached to your assets. So now that is also helpful from the financial standpoint, right? So if most of you who have worked in the managerial role now, you need to work with finance at every end of the fiscal year to go through the depreciation cycle, the equipment depreciation cycle, to understand that, hey, if I have a 5-year-old boiler, with this equipment efficiency, how much dollar value it has right now. So equipment efficiency, depreciation, everything goes hands in hands. So that is what a well-designed CMMS can help achieve your goal. So again, you need to go back, rethink what is your use cases and how or which system will help you resolve those use cases. So before we moving on to the next slide and next topic, which is FCA, I would like to ask everybody that, did you guys hear this terminology called FCA, which stands for Facility Condition Assessment Framework? Or have you used it? How much are you familiar? So you can say yes, no, or not sure. Oh, so I'm seeing not sure and most of 100% for not sure. So that's interesting. So let's go and talk about FCA. So FCA, as I said, it stands for Facilities Condition Assessment, right? So if I give you a brief context about where it all originated, so FCA, Facility Condition Assessment, it firstly originated in early 1970s, right? So I'm talking, we are sitting in 25, so almost 70 years ago, this concept originated, and the early adopters in North America were universities and healthcare facilities. The reason behind that they were getting into more and more complex engineering design within their facilities. Their maintenance costs were going really high, and they wanted to have more structural approach when it comes to the capital planning. So that's where they started looking into this concept. And then as the year passed by in early 1980s, it got affiliated. It has a registered benchmark. And in starting early 2010 decade, now we got into the SaaS model where we have the digital technology that can help you run this entire process and provide you with the final outcome. So how does it work? So let me explain you in a more basic term. FCA meaning is the company will come and it will tell you. So for an example, if you're running a food and beverage plant, or if you're running an automotive plant, and if you have five, I'll talk about the utilities. If you have 5 boilers and you want to know out of those 5 boilers, what is their health? As of 2025, if you have a 20-year-old boiler, if you have a 10-year-old boiler, regardless of their age, what is their life expectancy left? So that's where FCA comes into place. So in my next slide, I want to talk about the 3 core fundamentals. So how FCA works. First, it talks about the condition. So it tells you once the entire process is completed, once the entire inspection is completed, it will first thing is they will tell you what is the current state of the condition. If your boiler is 20 years old, if you have already done a corrective repair for almost 50 times, if you have already replaced and rebuilt the gearbox, if you have already replaced the motor for 5 times, that will tell you what is the condition. Now it will go back, that condition, they will take it and they will compare it with the OEM, so original equipment manufacturer, and their specifications to tell you what is the expectancy life left after comparing with the OEM. The last, but what is one of the most important, is the risk factor. So now let's say after comparing the current condition with the overall health, according to the OEM, now I get to know that, hey, Ronak, out of your 5 boilers, one of them is running at 80% capacity, one is running at 70%, and one is running at only 50%. So now, based on that, they will provide me a risk factor. So the final outcome I will get is what we call is a facility condition index, and that will be in a percentage score. So let's say if I'm told 20% percentage score for one of the boiler, that means that it might only last and stay operational for next 1 year. So based on that data, based on that most accurate data, I can feed in that information into my capital planning process. So how FCA can help manufacturer? First, it can help you in your current day-to-day operation by telling you the current state of the condition. So that can help you with your CMMS system, day-to-day operations, allocating budget, monthly budget, allocating spare part invoices. That's all fine and done. The second piece is now based on that risk factor, now you can support and leverage that information for your capital planning process. So FCA For if you ask me, it's an integral part of your asset management process because it can feed you into your CMS journey, and it can feed you into your capital planning journey as well. Okay, so we did talk about FCA and how it can help into the capital planning. So the next piece, I would like to talk about the entire capital planning process and the what we call ALM, asset lifecycle management. Most of you who are currently working in maintenance or project or engineering must be familiar with this design, what we call asset management lifecycle. These are 4 different stages: planning, acquisition, operation and maintenance, and disposal, right? So data, technology, the historical and real-time data, and that's where my colleague Hanara will talk about real-time data as well. But both historical data and real-time data information help you enormously when you are talking and when you are planning for your projects. I can give a really good example. So I was one of my company, I won't talk about the company name, but that company, I was installing a brand new cooking deck, and that cooking deck was one of my major customer, McDonald's. So the data, and you can understand McDonald's customer, they have a very rigorous data, very rigorous R&D and product development team who I was working very closely with. So on that information, I had to go back and forth working with the third-party equipment manufacturers, providing them the R&D data, product development data that, hey, this is what I want, this is the texture I want, this is the thickness I want, this is the viscosity I want out of the product. Based on that information, we created and implemented and executed that entire project. So the moral of the story here is, whether you are in your planning stage, acquisition phase, operation and maintenance stage, or when you're at the disposal stage, every stage you require some sort of a data to justify that stage. If you're talking operation and maintenance, as I just talked about in my previous slide, you need all your data, whether it's a historical data or real-time data. When you want to dispose of, you need your finance data, which I talked about the depreciation past. In my previous work life, I had to write off 3 forklifts because we weren't using it for years because it was broken down, and the cost to repair that, it wasn't justifiable because the amount of cost it had on my finance sheet. So what can I do? The finance said, hey, you still have $16,000 left for the forklift, but to repair and to use it is $40,000. So how do you justify? So that's where the data helps to make you a business case where you can take it back to your one-up, in this case, C-level executive, to explain them the scenario and come up with the final outcome, right? So if you're doing any sort of a project, always make sure that you need to go with every stage of this project stage with data availability. Okay, so the next is data integration into capital planning. So this is a very key notes. I think I already touched base on that, but make sure you do the financial analysis. And this terminology, and it become very, very popular in last minimum 5 years, what we call ROI, which stands for return on investment, right? Before that, I was never asked to showcase what is the return on investment for any project I did, but right post-COVID, that was a rigorous standard that most of the companies started implementing that talks about ROI. What is the return on investment? So if I'm investing, if the company is investing, for example, $150,000 in buying a brand new cardboard compactor, what is the ROI, right? How do you calculate ROI? ROI can be calculated in dollars. So let's say if you increase your production by 5%, that's an easy math. If you're increasing your efficiency, that's an ROI itself. If you're reducing your labor, so the new cardboard compactor might need 1% versus the old one, which needed 2%. So now I'm eliminating one labor. That's an easy math as well. So again, you need to come up with some sort of an ROI calculation. Most of the company right now feel comfortable if they have a less than 3 years worth of an ROI. I have done most of my projects that has less than 2 years worth of an ROI attached. But just to keep that in mind, whenever you are doing some sort of a capital planning process, do some sort of an ROI calculation, whether it's an efficiency, whether it's a time, whether it's a labor, and whether it's a production enhance and efficiency. Risk management, always do the risk management. That's where also you need data backup, and that's where you go back, leverage the historical data, leverage the FCA data, and according to that, you can prioritize. So let's say, for an example, how you do the priority assessment. The FCA data is telling you need 2 boilers in the next 2 years. One of them is only 20% efficiency left, and one has a 50% efficiency left. So that's where you prioritize. The first year, you would replace the one which is only 20% left, and the second year, you will replace the one which still has 50% of the life expectancy. So even for the priority assessment, as I said, all you need is a strong, accurate data to justify your business case, right? Because without data, making guesswork will not take us anywhere else. And based on that, you can allocate your budget accordingly, because now you have your priority set. Now you have already done your risk management. The next step is very easy. Allocate your budget based on the priority, right? So everything goes step by step. This is all 3-step process which I had followed and which made me successful in all of those projects that I led. Okay, so I think I did talk a lot about historical data, CMMS, and capital planning and FCA. But now, at this moment, I will pass it on to my colleague, Hanaro, and he will take us from here. Hanaro?
Hey, thank you, Ronak. Hey, good morning, good afternoon, depending on where you guys are located. So I'm going to talk about predictive maintenance and about how Brightly and Senseye work together to give you that closed loop maintenance solution, right? It's all about streamlining our data. As Ronak mentioned, data is cool, information is better. So it's what you do with that data that you have. Because everybody here knows that you have pieces of equipment that have very important pieces of data within them. And you know, with the rise of Ignition, with SCADA systems, MES, cake systems out there, you're starting to collect that data and you're starting to play with it. You're starting to formulate OEM dashboards. But there's so much more potential there. And it's about utilizing that data from your assets, right? Feeding them into AI and actually using AI in a real world scenario, taking that real time data, getting predictions, getting forecasts on failures. And then the closed loop maintenance part is utilizing Brightly work orders, utilizing all that data that's stored from your maintenance people and filling in that gap, right? We're experiencing a gap in the market now where in an all industrial manufacturing operations, you're having issues with operators, you're having issues with your maintenance guys, your senior people are exiting the workforce, and there's a gap. So it's about capturing that information, capturing that knowledge and expertise, and having it all feed back into a tool that you could exploit, right? So that's what actually utilizing AI in a real world scenario means. So when you look at traditional maintenance events, you're talking about being notified of an issue when an operator notices that there's an abnormal noise or the machine stopped. You have a fault on the HMI screen, so a maintenance operator is called over, right? Your maintenance engineers, manufacturing engineers, your line techs, all of these people show up with very limited information to the event, and now they have to troubleshoot. And not only do they have to troubleshoot, but they have to do it in a high stress environment, right? We all know how critical it is to get equipment back up and running. I'm talking from experience. Leaving the Navy, I started working as an industrial electrician in the automotive vertical. So I know that my number one priority was restoring that equipment back to operability and getting the operation back up and running. So it's safety involved in that. It's, did I get it right? Not verifying, trying multiple things around the machine to get it up and running. And if it starts, great. You watch it run 5-10 minutes and it takes off and it runs for the rest of your shift, you're okay. But it's that part of verification, that missing link of getting that closed loop audit, right? Of actually knowing that your maintenance action was efficient, that's missing in a lot of our teams and a lot of our cultures, that goes into developing a larger complex problem. Something that maybe needed lubrication or alignment turns into 10 small downtime events and then generates a big downtime event that has mechanical and electrical failure. Then now you have a major downtime created with all these other little stops that go along the way with that. So how does AI actually help you? Help your maintenance teams, help your engineers, help your quality guys in real world scenarios? Well, we developed Senseye to help you in 3 very specific categories that actually streamline that entire event. So number 1, your team is going to be notified by an attention engine, right? And it's that ability to create notifications when you need them and eliminate distractions. If I have a system that's just generating alarms for your guys, eventually they're going to stop looking at them, right? They're going to ignore them. You're going to be like, whatever. It's all false positives. Who cares anyways, right? So we understand that getting notifications, getting the right notifications, getting a high level of fidelity when it comes to accuracy, and then eliminating false positives is very critical when we talk about predictive maintenance and an alert notification system for your maintainers to actually keep them engaged and focus on the equipment that they actually need to perform actions on. So this dynamic AI-powered notification system allows us to do just that. Now, this notification system is powered by another AI engine that runs in the background, which is all ML analytics. It's the way we go about creating models. Now, why is this important? What differentiates Senseye from anything else out there? These black box systems or these other predictive maintenance solutions where they're solely model based on data scientists creating very specific sets of data and data algorithms for your equipment. All those things are nice, right? They're good. I'm not saying they don't work. They work in very specific scenarios, but when you alter that scenario, you change the speed of your motor, you change the recipe, you change the product that you're running, then you might as well throw all that out the window and start back over again, right? What we notice is having and leveraging ML to automatically create models from the bottoms up approach, kind of like Ronek's pyramid there. We're going to start with the measures and creating models around measures individually. Then we're going to create a measure or a model that encapsulates all of those smaller models within itself. And that's going to be your asset. That's going to be your motor. That's going to be your pump. That's going to be your robot. And then based on that, we're going to create different models that mirror the equipment operation, its function, right? If you're running an auto, I'm going to filter out all the data. I don't care. If I am running in recipe A or recipe B, product X, product Y, I'm going to change the model and I'm going to create models based on what you're actually running. So I'm going to have very, very, very high fidelity and accurate models built because I have an understanding of what your equipment is actually doing. Now we have that portion covered, right? We have our data. We transform the data into information in the way of notifications for your maintenance teams. Now your maintenance team is notified that there's a potential issue, a forecasted issue into a piece of equipment, whether it's a robot, whether it's a welder, whether it's a pump, a conveyor. They're going to have a notification to go do something. They're going to see a measure, and any other solution out there is going to give you an alert. It's probably a threshold-based system. You get a 0 turning into a 1, and now it requires an action. But you still don't know what to do, right? And that's where that gap comes into play, that knowledge and expertise gap. We included GenAI into our tool within the last 6 months to help bridge that gap and gather all the information from Brightly, from your work orders, gather the information from your maintenance teams, gather information from the ML analytics, gather information from my notification process, my notes, everything that comes together from this UI will actually give me a very prescriptive portion, right? That prescriptive maintenance culture where I actually have a dialogue that guides me through what is going on with my piece of equipment, why the application has notified me that there's an issue, what that issue potentially means, and then what the most important thing, how do I go about fixing it? And then once I do take an action, all that closed system-based solution that I just talked about is having a work order done, having that data from that work order automatically fed back into this application, the co-pilot learning from your action and saying, okay, this specific event meant this, right? Meant this particular maintenance action, and then having the audit, right? Having the action take place and then all the measures return back to its normal level of operation, which is the piece that most of us are missing. And understanding that what I did was actually effective and did solve the problem at its root cause. Now, Senseye itself works just like the pyramid that Ronek showed when he started his presentation, right? I mentioned that we're going to have a bottoms-up approach. The very base layer of that is going to be your factory networks. It's going to be your assets, right? The data sources themselves. Now, I mentioned how Brightly comes into the picture, how CMMS ties in, and the work orders are very valuable pieces of data. All of that is categorized under your maintenance data, your preventive, your corrective, your reconfigurations, setting changes, anything that you do to a piece of equipment that allows me to filter out information and give the system a better understanding, I'm going to take. The operational data that comes from your PLCs, that comes from your controllers, your DCS systems, that lets me know if a system is running auto, whether it's running manual, your teach pendants. If I throw that in teach, then I don't really care what my disturbance torque on my axes are for my robots. I know that you're running it in manual and that is not running its normal operation, right? So I'm going to filter that data out. I'm going to focus when the machine is running and then what product or what recipe, what weight, what speed that particular process is running at. The condition monitoring data comes from your assets, from your motor, from your drives, from your sensors, from your PLC, from your DCS. All that gets fed into the core platform of Senseye, which is 3 different AI engines running. They're all layered together to give you the detection diagnostics and forecasts tools that you see as anomalies, trends, and step changes in diagnostics. And all of that is controlled through the attention engine, which actually filters out false positives and is dynamically changing the status of an asset as I see it, essentially a health status as I see it as a maintainer on the UI. So I only focus on what is truly in an anomaly state and what is truly degrading, right? So I'm going to jump in and I'm going to show you guys the tool itself, right? I think that's the best part of this. I think you guys are going to get a better understanding from the tool itself than from me trying to break down the tool within slides. So I'm going to jump into that and give me a second here. All right, perfect. So you guys should be able to see the tool itself. This is the UI. It's web-based, so that means you could deploy this on any web-capable device. So I have clients that deploy this on tablets. I have clients that deploy this up on screens outside their maintenance shop. All these accounts, there's no limited, or we don't apply a limitation to how much users utilize this, right? It's all about having this data accessibility and then transforming that into information that's valuable to your quality guys, your production guys, your maintenance guys. So it's far more than just getting notifications on failure. It's understanding your equipment and then how your equipment operated during certain circumstances, and then utilizing that information to go about planning your maintenance actions, understanding where some quality defects came from because you have the status of your equipment. So what we have up here is a navigational level. This layer allows me to create a customized way of navigating through the solution, right? This could be a global map that gives me a representation of all my plants across the globe and gives me a status indicator and an insight into those things. And as it pops up here, you guys will see that. Right? You'll see a map with several industries here, and I could jump into those. But as you see those, every single layer that I could jump into has a health indicator. That health indicator is going to show me the highest level of attention case that's within that specific sector. And as I navigate through those, you'll see all the information that's down below, the list of cases, and then the information on those cases be filtered to the specific level of navigation that I'm in. I'm going to jump back into the level that I was showing previously, which is a level that we created for some of our shows. So we're back, right? We're looking at this very customized imagery, and we have different sections here, all with a condition indicator on their own. But I have one that's in red, right? I want to focus on red. So if this was my area of responsibility, I'm going to jump in here. Now, I could see that it's further broken down into this very specific area. Now it's limited to the 3 assets with 3 cases associated to the area that I'm in. I'm going to hide the map because we're going to focus in on the information and then how this tool actually works for your maintainer and for your quality guys, for your manufacturing engineers, for the people that are using this, not data scientists, right? Easily could be used. We have things where you could exploit algorithms using derived measures within the application, but the tool is really designed on the front end for the specific purpose of solving problems. So let's go ahead and do that. So I have a pump. I have an anomaly here. It says it was opened 12 days ago, so I get a date stamp And then as I navigate through these, you'll see that the information on the right-hand side, my right window, is going to change depending on what case I have open. So I'm going to focus on the critical one. The Copilot is the newest addition here. And as I mentioned, it's going to give me the prescriptive portion of this tool. So it's going to let me know what's happening. It's going to let me know that I have a rising trend, that I have a correlated behavior on these other measures. And as you see, they're all velocity. I have RMS, I have peak to peak, which lets me know that these are coming from vibration sensors, right? But I don't need to be an expert. I don't have to know that to go in to actually have some impact within my maintenance team. So as I navigate down, right, I see the historical information, the data, the anomalies, the evidence that the application is trying to show me. But the best part about this is the possible explanations. It's going to let me know, hey, it's very likely that you're running cavitation, or that you're dry running your pump, that there's an issue with misalignment or wear, or that it's normal behavior due to operational cycles as its last possible reason why I'm experiencing this rising trend in my measures. Now, the information doesn't just stop there, right? I have the ability as a user to interact directly with the Copilot. I could ask it, what actions should I take to resolve? And the application is going to give me the reasons, right, as it previously stated in the ACID window, in the case window, I'm sorry. But it's going to break it down a little bit further. And then it's going to let me know where that documentation is coming from. And this is key. This is making a system that has the ability to ingest data, making it smarter via the manuals that your OEMs provide when they ship you your systems. OEM manuals from your pumps, OEM manuals for your motors, your VFD, your drives. All of that information being stored here so it's easily accessible for the people doing and planning maintenance actions. So I could see I have a machine passport template. I could see I have asset data, I have failure characteristics, and I have contextual information that allows the system to understand where this data comes from, what it means to the system, and then what failure characteristics the pump can experience based on the data that it's collecting, right? So it has an understanding of where these things are coming from. Now, it's not limited to just that. This is where CMMS, where Brightly come into the picture. If I had issues that have with other pumps, or with this pump a year ago or 2 years ago, and something similar is happening now, if it's happened before, the system's going to tell me, right? It's going to reference old work orders that let me know, hey, I've seen this before, it means a lubrication. I've seen this before, it means alignment, right? So I'm going to ask it just, what documented work do you have on damaged seals? So it's going to let me know that it does have a maintenance log entry dated October 24th. It's going to let me where that document is located, who the technician was, what type of work was took place, the cause of damage, and then it's going to give me the link to the actual work order itself, right? And it's not limited to just understanding text. We have a state-of-the-art VLM ingestion system that breaks down imagery, right? So you could put flow charts, procedures, yes and no decision points, and all of that be stored within the system to be available for your maintainers, for the people that need it most when they need it most. I know we were running out of time here, but I want to leave a little bit of room for some questions here at the end, and wanted hopefully you guys to understand, that closed loop maintenance that comes within predictive maintenance in Senseye and Brightly. I am going to talk about, a little bit here about what this actually does for your equipment. The robot reducer replacement, this is a success case where this is what the system actually looks like. For the automotive people that are here, you'll understand the complexity of taking an action on joint 2 on that reducer, especially if it's a heavy, big robot, having a counterbalance system, and then having to hoist and remove all the weight off of it, take the gearbox off, take the motor off, replace that, getting it all back together, and then hopefully you don't have to master your axes, and then verifying every single point. You're talking taking a 4-hour maintenance event for a very, very, very experienced group of people. Now, if you don't have that within your facility, you're talking about 8+ more hours to get all of that done, right? It's a long period of time to be without your piece of equipment, especially a robot that shuts down your line, right? We know the type of impact that has. So when you look at disturbance and you look at torque on your axes, you could have up to a 5-month lead time where you have a clear view into what's going on with your equipment and plan that ahead of time. Know that gearbox is going to fail. And instead of doing it on the fly while production is running and trying to move your operators around because they're done for the day, planning it on a downtime event, planning on a PDM, on a preventive maintenance, predictive maintenance Saturday or Sunday, and having this work done on your time and on your schedule by having the equipment plan it for you. And yeah, that's it, guys. That's it on me. So hopefully you guys enjoyed the presentation, and I'm excited to hear what your questions.
Thank you both. That was fantastic. We do have some questions here that have come in. The first question that came in here is for Ronak, and it has to do, the person is asking, can you explain what would be the first step in explaining to a manager how to make the case for an asset management system?
Yes. So for the first case, so depending on the maturity level, and this is how I see it, and this is how I pursued it in my previous career. So the first thing is you need to have some sort of a business case, and you have to tie in that business case with the production and with the overall quality. Like, by implementing asset management, you will have, let's say, I'm just throwing the number, 5% more production by end of 2025, or you can increase your facility conditions by 15% or reduce maintenance cost by $100,000 on a monthly average. So something, as any project, you need to tie in the numbers, you need to tie in the data that can reflect. So if I'm a plant manager, if you come to me, and if I'm a CEO, and if you tell me, hey, I just need the asset management without having any context behind it, it's not going to make any sense. So only and unless they understand the impact, you need to make sure your business case has an impact on your company's overall organization wide. So as I said, go with your production numbers, go with your maintenance numbers, or go with your overall expansion numbers, something which is more visionary or more strategic that can align with your C-level executive mindset.
Thank you. Similar question for you, Hanaro. This person is asking, when talking about sensors and AI, how can we make the case to leadership that this will improve the production process and improve output?
Yeah, absolutely. So we conduct assessments, right? ROI has already been mentioned here a couple of times, and ROI is a big building block to proving this to leadership on how a application like Senseye could have an impact within your specific environment. So we assess downtime that you're currently experiencing, right? And that goes not just breaking down hour-wise how much product you're losing, but goes into labor, it goes into all the things that actually impact a downtime event. And then we calculate the type of efficiencies and the increase in productivity and sustainability within your equipment by reducing that downtime. Just to give you an average, our clients experience a 30% reduction in downtime within the first year, and within the second year, they experience up to 50%, right? And that's huge.
Great. Here's another question for Hanaro. Are the first two steps of data gathering from the day of Senseye implementation, or does your team pull in the history that we already have?
No, that's a very good question. So we do both. We could pull in historical data to kind of train the system and get it ready and look at deviations that you've experienced previously. But we're mostly going to start the attention engine, which is what actually runs the application, day one. Right? So from live data. And the reason why we do that is because all of those AI layers are interlocked with each other. So when there is an anomaly, the system expects result in actions. And without those actions in your historical data, it skews the way the attention engine perceives like step changes or peaks within your data. It perceives those as normal operation without any active feedback.
Fantastic. And we have one last question that appears to be for the both of you. And it says, knowing what you have explained in this presentation, how would it have changed both of your manufacturing experience when you were working in manufacturing?
So I can go first and I can talk about it forever, right? Because as I said, I worked in operations, I worked in maintenance, and I worked in engineering. So those are three different pillars of the company. But when I talk about these asset management and all these manufacturing practices, before when I was, and I won't talk about the company, but we didn't have any data. And that's where we implemented the SCADA system. We implemented the brand new CMMS system, and we started tracking the data. The very first month were chaotic because first, change management, trades, maintenance, unionized companies, they don't like it, right? So first thing first, the change management was a hard piece, and that's where we have to get over with the people skill. But then the second piece, when people start seeing the impact of the data onto your day-to-day or into their day-to-day operations and their work life, that's where the magic starts happening. So let's say if I'm a first line operator, and if I say that, no, now Ronak's team is maintaining this piece of conveyors very well, so I don't have to go and take that cardboard away every 5 minutes. It's taking away a lot of my headache. Now I'm seeing that improvement slowly but steadily it's coming out. So as I say, it's a journey, and that's what I have it on the screen right now. It's a journey. Asset management is not like a flicking the switch. You start, it's a baby steps, but as soon as people start seeing the difference, people start seeing the improvements around them, they will start putting more trust and they will start getting more engaged, especially around working around the unionized company, working around different diverse group of culture. That's what I would like to say.
Yeah, from my end, unfortunately, when I came up working as an industrial electrician, these tools weren't around, right? Copilot wasn't a thing. I didn't have access to a Gen AI capable system that could walk me through some of the issues and walk my teams through some of the issues that, are experienced in industrial manufacturing. But the way this would have changed if I were in that environment now, I mean, it's a huge impact. Number one, like Ronak said, it's a journey, right? Predictive maintenance is not magic. It's not something that I'm going to be able to just walk in your facility, open up a box, and then you're going to start getting predictions left and right, and the system telling you that something's going to fail at 3 p.m. on a Friday. It is definitely exploiting data, understanding where the gaps are, doing assessments, and then taking the data that matters, putting it into a system to give you tangible results, and then those results having the type of impact where me as a maintainer utilizing this tool not only affects my level of attention, it reduces my stress. I'm able to focus on the piece of equipment that need it. I'm able to plan things in ahead, which is the biggest thing, right? Is understanding whether I have the components at hand to make a certain repair, talking to my production guys and being like, hey, I need 30 minutes here. I need an hour over here. When can I do these things? And then having those things be planned out without a system running, which affects safety, right? Affects my troubleshooting, doing things under power. And everybody here knows lockout, tagout, right? But realistically, like, are your maintainers following that type of procedure, every time there's a downtime event? And it's taking all those things into consideration when you're talking about a journey of this magnitude.
Awesome. Thank you both for answering those questions and for the fantastic presentation. This concludes our webinar. Thank you so much to everyone for attending. As a reminder, the recording will be available soon. You'll receive it in your email with information on how to view that recording and how to share it with others. And as always, if you have any questions, you can feel free to reach out. And we look forward to seeing you at our next webinar. Those are always available on our LinkedIn page, and you'll get more information via email about our upcoming webinars. Thank you so much, and enjoy the rest of your day.
Please like and subscribe on all major podcast channels, and find out more about Senseye Predictive Maintenance at Siemens.com.